A lot of people ask me questions about how to simplify a radical, and the method that I like to use is I like to use the factor tree method. What that does is it takes your number and it breaks it down into prime factors. So 8 breaks into 4 and 2, and 4 breaks it down into 2 and 2. What I look for, because it's a square root, is I look for pairs. Here's a pair of 2's, so I can take that on the outside. And whatever's left over that has not been broken down further, like this 4 has been broken down further, the 8 was broken down further, but this 2's left over, I'll just put the 2 back on the inside. So the square root of 8 turns out to be 2 square root of 2. You can break 54 down into 2 and 27. Doesn't require a whole lot of creativity. You can just divide things by 2. Maybe divide things by 3 if you really can't think of what's going on. And then divide this by 3 and 3. Again, we're looking for pairs. There's a pair of 3's, so I can pull that out. And whatever's left over that was a prime factor, those go on the inside and are multiplied together. So that'd be 3 times the square root of 6 is my final answer. Same thing happens with this 8. This would be 4 and 2, 2 and 2 again. I look for a pair. That pair comes out as multiplied by this 3, which is already on the outside. So that 3 just comes down. We have a pair of 2's. What's left over is the 2 on the inside. This becomes 6 times the square root of 2. Next, we'll take a look at these when they have some of these exponents or these variables in here. Again, we break down 27. Maybe that's 9 and 3. This becomes 3 and 3. X just gets broken down into just x and x. I look for pairs. Here's a pair of 3's, and here's a pair of x's. So on the outside, I have 3x. On the inside, I have the square root of 3. 300, you can break that down into 103. You could break 100 down into 2 and 50. 50 into 25 and 2. 25 is 5 and 5. I'm just looking for pairs. Here's a pair of 5's. I can take that out. Here's a pair of 2's. I can take that out. Again, those are multiplied. What's left over is this 3. That gives me 10 times the square root of 3. Some of you might be asking, well, could I have done this differently? Can I break this down differently? Well, you sure can. As long as you break these down into perfect squares or into prime factors, you're going to end up getting the final answer the same way, even if you find different pairs or different groupings. So it's not a huge deal. This is a little bit more complicated. We'll break this down into 16 and 3. 16 is 4 and 4. 4 and 4 are 2 and 2. 2 and 2. The A's, we'll just say A, and A. We have B, 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 and B. And then we have 6 C's. I'll just label each one of those right here. And again, I'm looking for pairs. Here's a pair of 2's that I'll put on the outside with my 1/4. Here's another pair of 2's that I'll put on the outside with my 1/4. Here's a pair of A's. Here's 2 pair of B's, so I'll put 2 pair of B's. Here's 1, 2, 3 pair of C's, so I'll put 3. And I gotta figure out what all is left over. I have a 3 left over, I have an A left over, and a B left over, so that's 3AB. I'll simplify one step. 1/4 times 2 times 2 is just 1, so all that goes away. I then have A, B squared, C cubed times the square root of 3AB. At times it can get a little complicated. You just got to kind of keep track of breaking things down in their simplest form, and then all you do is you look for pairs. If you need more help on simplifying radicals, check out my next video.